Welcome back to another Micro Soldering Wednesday. My name is Derek, and today we're going to be going over something simple that might help you in the future. Let's get into the video. Today we're going to be taking a look at these two motherboards. These are Nintendo Switch Lite motherboards, and they both have the same issue. Somebody has damaged one of the connectors. And this connector is important because a lot of stuff connects to it, but it's also a component that's made out of plastic. And plastic melts. And it happens to also be right next to another very melty connector, which is the battery connector. So I'm going to show you step by step how I go about replacing this connector so that we don't melt the plastic, so that we get a nice solid joint. So these can go back and be used once again. Let's get started. So as you can see, we are missing the little flap that goes on this connector. I've got this extended over the edge of my table so that I'll be able to heat it from below. Don't want to melt this connector. Don't want to melt the plastic on the charge port. And we don't want to mess with anything over here. So we're going to focus all of our heat directly under this. Basically, I've got a reduction nozzle that'll just be right there under it. We're going to be using some flux. So we'll go under the microscope. I'll show you how this works. All right, so as you can see, we've got this plastic connector right next to it. We get the charge port over here. And here's a new connector, just so you can see what this looks like. You can see we're missing this white flap here. And this is a tricky one to solder with an iron because of the little components right here. So this is all done without a soldering iron. Or you can technically do all of this without a soldering iron. I'm going to turn on hot air and take it up to 400, 450 degrees. And I'm going to heat it up from below. Take a little bit of flux. This will just help the solder not oxidize as much as we heat it up. Now there's nothing off to the left of the connector, so I don't really have to worry about sliding it that way. I would have to worry about sliding it to the right because I would knock stuff off. What I'm basically going to do is wait to see everything turn nice and shiny. We're almost there. I think we're pretty much there. So now we can just gently push it off. Like that. And what's kind of nice is we'll just keep the heat going here. Get our new connector out. We'll line everything up while it's still warm. Okay. And then we'll come in from below. And we'll watch everything grab on. We'll count 1, 2, 3. Pull it away and let that cool down. What you'll be able to see is all of the joints have kind of a nice little ramp where the solder is definitely sucked up and onto the pin. It's no longer a pillow of solder. So now we can take a look at this at an angle. And let's zoom down in on there if I can stop shaking. And you can see we've got nice solid connection of solder between all of the pins there. Let's flip it over and look at the side where the flex slides in. And again, if I can stop shaking so much, you can see, even though I'm shaky, nice solder joints all the way across. And it's that simple. This one's fixed. So let's do the other one real fast. In my little clamping fixture here, zoom out. And it looks like this coil is off, so I'm going to move that back too. Put some flux on that, flux here. And I'm going to clean up the other board, the flux off of it. I will take some time to clean it off with some isopropyl alcohol. We'll get our new connector ready. Alright, here we go. Heating from below. Put that coil back. It's under it. Looks like we somehow grabbed the cap next to it. So We'll line up that cap where it needs to go. We'll put the coil back as well. Line up the connector. And we'll do all three of these things at once. Alright, I'm more or less happy with that. So let's go ahead and heat it up from below. See if that cap will snap back in. The coil already went down. There's the capacitor there. Okay, and there's that connector. Let's let things cool down and take a look at them real fast from the side. And that looks really clean. Looks really good. Except for one pin. Let's see if I can. Looks like I'm going to have to break out the iron. That third pin is floating above it. It looks like it almost got bent up. Yep, we're going to have to push that one down. I guess we do have to use the iron in the end. Line this up. We can see it. Alright, so we'll get out our iron. This won't take long. But you can see how this is solid, and this one moves. I'm going to need to pin it down and then tack it in place. Alright, here we go. So we'll push it on down. And I don't know if that did it, so I'm going to add a little bit of flux. Yep, that's down. Let's look at that again. Alright, they all look nice and good. And we can hit it with some isopropyl alcohol. Come in with a brush. Now coils typically bridge data lines together. So someone was probably troubleshooting something. That's why it was slid off to the side. And here's a tech tip. Right before when you're done, you take a cloth with the alcohol and you rub it. And what will happen is the cloth will absorb all of the residue and leave you with a really clean surface finish. No residue of flux or anything. So here's the first one, isopropyl alcohol, and that's that. And that's how to replace the connectors to get a beautiful result. If you have any questions, leave them in the comments below. These can now be used and enjoyed once again. If there's something that you'd like to see in a future video, let me know. Thanks a ton for watching. We'll see you in the next video.